Film number 3 is about a situation where we have 2 or more sensors. So let's say in this example that we want to measure a system where this is a sensor and this is a sensor. They can, for example, be temperature sensors. And what we want to measure is not the exact temperature, but the temperature difference. The difference between 2 temperatures. Or it could be 2 forces or 2 levels or whatever. But in this case, let's say temperatures. Now, note the numbering scheme here. 1, 2, 3, 4. Which is a bit different from what I used in the handmade drawings. But still, the equation is the same. It's this one over the sum of the 2 on one side. Here. And on the other side, I have this one over the sum of the 2. That it compares to here. And then I have a minus sign between the 2. And it depends on where I would like to put my positive probe and where I put my negative probe in the voltmeter. So here, the positive is to the right hand side and the negative to the left hand side. And therefore, it's the right hand side minus the left hand side. So let's say that the 2 here are temperature sensors, like this. The equation for the temperature sensor is given here. That's the PT100, where R0 is 100 ohms, and then you have the sensitivity of the device. Let's also put here, so these are PT100s, and this is a PT100. Let's say that R1 and R4 are fixed 100 ohm resistors. So they have the size the same as R0. Now let's put that we have the basic equation here. Let's put in the expression for the sensor, and the fixed resistor. The sensor, and the fixed resistor. So we put that into the equation. Sensor, fixed. Sensor, fixed. Put that into the equation, and then we tidy up the new equation from here to here, and we end up with this. Now that is a function. V out is a function of the temperature difference between T3 and T2. So therefore, this is a differential measurement system, which measures the difference between 2. Quite useful in some applications. What about if I have, like this setup, 4 strain gauges, which is very common. And we will see in a minute why it's very common. In that case, I have to arrange them like this. The 2 strain gauges that are stretched, they must be placed diagonally across each other. And also the 2 that are compressed have to be placed across each other. If I place it like this, compress, stretch, then I'll get no result from the measurement. I will measure 0. Also, compress, tension will result in nothing. So I need to have compress, tension, or like in this here, compress, tension, diagonally across each other. Now, if I do that, the equation for a strain gauge, R equals R0 1 plus G times E, where R0 is the resistance at rest, G is the gauge factor, usually a number between close to 2, and you have to find it from the datasheet of the strain gauge, and then E is the strain. So the amount of strain you attach to the strain gauge. So if you stretch it by, say, 2%, then 2% stretch, then E equals 0.02. So that's the amount of strain, which really is a fraction. Right, so I have this equation for the original bridge. Are 1, 2, 3, 4 numbered like that. And I replace it with strain gauges. For those that have tension, they will have increased resistance. Those that are compressed will have a negative sign there. So R3 in this case is one of the compressed ones, so it will have a minus sign. R4 is one with tension, so it will have a plus sign. R2 tension, plus sign, and R1 finally compressed, so it will have a minus sign, R1. So now I've replaced R1, R2, R3, and R4 with the equations for a strain gauge. I can fix this because the Arnolds, they eliminate each other. So I end up with this equation here. And also I end up by, let's see that the GE part here eliminates this one, and this eliminates this one. So I basically have the set number 2 in the denominator, 1 minus GE, 1 plus GE. And if I go one step further, this is the end result of the strain gauge equation. So the voltage due to strain becomes V minus Vx times G times E. Alright, so that was the strain sensitivity. So it's really doubled because I get a double-sided result. Now there is another effect to it as well. This here is due to also a change in the temperature, but all 4 here will have the same temperature. So let's look at what's happening due to the thermal sensitivity. The basic equation here again, the new resistance due to a thermal change, and these eliminate each other, and the final result is 0. So by using 4 strain gauges in a bridge, we eliminate parasitic thermal sensitivity while we double the strain sensitivity. Very important and very commonly used for strain gauges. So for strain gauges, you will almost always see a set of 4 when you try to measure something. For example, if we have this setup with a membrane, and let's say that we have air pressure here that pushes down the membrane. If you want to measure the strain on the membrane here, you really want to use 1, 2, 3, 4 strain gauges in order to get this effect. We'll double sensitivity to strain and eliminated sensitivity to temperature.